Okay, how about now? Can you hear me now? Ah, perfect, brilliant. Thank you. Good to see everyone. And today I've prepared some questions. Now I'm almost running out of questions because we never had this before. We never had 3 webinars on the same topic. We usually have maximum of 2 webinars on one topic, and then we move on to the next one. But because we've given you a lot of time to do the first assignment, more time than normal. This is because we are recruiting tutors that will teach you, that will mark your grade your work, etc., etc., etc. Now, on the 16th of October, we start marking. So by about, well, probably by the end of October, you will know if you're in or not. Okay. And just a quick reminder, the difference between you being in and not, that if you're in the program, you will have access to a tutor who will do tutorials in small groups. And if you don't get into COMPOS, into the program, you still have me, you still have weekly sessions with me. You can still ask me questions, and you can have access to all the materials. Okay, so I hope that makes sense. And we will start. So I've prepared just 5 questions for you. They're quite advanced. I won't be a tutor. I don't think I just have the capacity to do. Yes, you can resubmit your work. You'll just label clearly which bits. So the assignment is the physics and the maths assignment is the entrance exam. Okay, the deadline is on the 16th of October, and you will need to submit them on Google Classroom. So make sure you're in Google Classroom. If you're not, you need to send me an email. I have a backlog of emails, so if you've emailed me in the last few days, I haven't seen that yet, but I will go through my emails probably tomorrow morning. Right, so you can resubmit. Just label clearly which bits you want to remark. And don't submit the whole work. Just submit the question that you want. So put it on a separate sheet and say resubmission of question 8. Then we can remark that and put it and change your grade. Okay. Brilliant. So I'll share my screen and we will go through 5 questions, maybe more. Right. So this is a very physicsy question. So we have a rigid triangle ABC, and it is moving. It is moving. And we need to find the velocity of A, B, and C effectively. Right. Yes, all the recordings are published in Google Classroom. So if you go to Google Classroom, you will see you'll find all the recordings there. Right. So let's have a look at the question. We have a rigid frame. Rigid frame. So what does rigid mean in this context? What does rigid mean? That's a question. Yeah, you can answer. the chat, please. It does move. Yes, Alfie, well done. All points stay the same distance apart. No, it can move, but all the points have the same distance. So let's say if I draw a triangle on a piece of paper, A, B, and C, I can move it. I can move the triangle, but the distance between the points doesn't change. Right. Therefore, we know that C is moving with velocity v, and it's moving towards A. And we know that A is moving along the hypotenuse. And we need to figure out velocity of A and velocity of B. Okay, so that's interesting. So let's label the velocity A. Velocity A, and just put a label. Let's say this is V, velocity of A. Now, A and C, they are moving. And because the distance between A and C is not allowed to change, this is the year 12 webinar, yes. The distance between A and C is not allowed to change. Therefore, A and C have to have the same horizontal velocity. Okay. A and C have the same horizontal velocity. All right, A and C have the same horizontal velocity. The I drew link. Okay. A and C have the same horizontal velocity, and you can. Does everyone understand that? If you, how well do you understand on a scale of 0 to 10? How well do you understand that? Okay, the horizontal velocity of B. We don't know that. We do. Well, we will figure it out later on. But yes, A and C have the same horizontal velocity because along AC, A and C are moving together. They have to. Because C is moving, C has to move with the same speed in that direction. It is allowed to move downwards as well, but in order to keep the distance constant, it would be the same. All the recordings will be published. Okay. Now, because as distance AC is fixed. Well, if you don't fully understand, imagine a train. You have the front of the train and the back of the train. Whatever happens, the front of the train has to move with the same speed as the back of the train. If the front of the train moves with a different speed from the back of the train, then something is very wrong. Okay, just the same way, if you have a rod AC and AC is moving with a velocity, A has to move with the same velocity in that direction. Right. As distance AC is fixed. So therefore, if I break this down into components, if I break VA into components, this is VA cos phi, and this is VA sine phi. And therefore, VC, or this, or which is V, VC is V, has to equal to VA cos phi. So VA has to equal to V divided by cos phi. So we found VA. We know the direction. The direction is along the hypotenuse. So we just need the magnitude. The magnitude is V over cos phi. And now let's look at B. Well, we're using the same logic. CB is fixed. So CB is a fixed distance. So B and C have to have the same velocity along the rod BC. VA, yes, Pythagoras. Well, look, you need to be very confident. Sorry that I'm being sidetracked. If you have a vector, you need to be very confident with breaking it into components. If you have a vector f and an angle theta, this is f cos theta, and this is f sine theta. It is a consequence of trigonometry. I won't get into that. This is in the assignment, so please read the assignment. But this result, this is a very important result, and you will be using it a lot. So if you're not confident how this works, just go reread the assignment and make sure you understand. I think there are plenty of links to videos, and I think there's an explanation of this fact. Okay, CB is fixed. So, and C is not moving in the vertical direction. Yes, C is only moving horizontally. Therefore, B is also moving horizontally. C is not moving up or down. Therefore, VB is horizontal. Okay, so VB has to be horizontal as well. And I'm assuming it's a little bit faster than C because A is moving down as well. So this is VB. Okay, and now AB is a fixed distance. AB is a fixed distance. So A and B have the same velocity along the rod AB. So now we need to break it into components along the rod and perpendicular to the rod. Well, VA is along the rod, so we don't need to break that down, but we need to break VB. I'm going to use blue for this one. VB, this is VB along the rod, and this is VB perpendicular to the rod, and this angle is phi. Believe me, it is phi. If you're not fully convinced, convince yourself that this is phi. I mean, not just not in blind faith, but try to work it out. Yes, Z angle, alternate internal angles. I prefer the proper name, but it's up to you. So, and this component, the bottom component, is VB cos phi, using the same logic as here. So the adjacent side is VB cos phi. And these two have to be equal. So this one has to be equal to this one, because they are along the rod. So therefore, VB cos phi has to be equal to VA. But VA is V over cos phi, which is V over, so VB cos phi equals V over cos phi. So VB equals V over cos squared phi. Well, let's put a bearing. Always acceptable to put bearing 0, 9, 0. That's for VB. Not the best way to do it, but and VA is bearing 90 plus phi. It looks a little bit silly, but I mean, it's understandable. As long as it is clear what you mean, bearing is 90 plus phi. Not so in physics, we normally say 5 degrees to the horizontal, or we say 10 degrees to the vertical. We very rarely use bearing, so I don't know. I just felt like it. And again, if it is clear what you mean, it's perfectly fine. Now, the next two problems are look the same, but if it was in an assignment, I would probably give you 1 mark for that, and I'll probably give you 5 marks for that one. Okay, 4 marks maybe. Right. So let's have a look. The first problem: a barge is pulled by 2 tugboats with force 3 newtons. Well, probably 3 kilonewtons. I mean, have you ever seen a barge being pulled by newtons? Doesn't really matter, but 3 kilonewtons and 5 kilonewtons. Find the resultant force. Okay, so it looks very straightforward. The problem looks very straightforward. And it is, by all means, it is a 1 mark question, maybe 2 marks. And then look at this one. A barge is pulled by 2 tugboats with speeds V1 and V2. And so the same speed, same values, same angle. The ropes are inextensible and attached to the same point. Find velocity of the point of the barge where the 2 ropes are attached. So it seems like as if they're asking for the resultant velocity, which would be exactly the same problem as problem 2. Yeah, because they're asking for the velocity of this point, V. So let's do the problems and see if it makes a difference. If it makes a difference if we're talking about forces or we're talking about speeds. Okay, so well, the resultant force of 2, you probably know how to do this. We use the parallelogram rule. So the parallelogram rule says that if you draw a parallelogram, the resultant of the two forces is going to be the diagonal of the parallelogram. And this is F resultant. I keep receiving notifications. How do I? Oh, I think that works. Keep receiving notifications from Telegram. Okay, so the resultant force. Well, you can use geometry here. So you have this angle is this is 3. This is square root of 5. And this angle is tan alpha. So alpha is tan arctan. Arctan 2. So this would be pi minus alpha. Okay. The resultant force. The resultant force okay, probably maybe 2 marks, but just because of the hassle with pi minus alpha. But anyways, you can use the cosine rule here. Using the cosine rule, the resultant force, yes, in radians, but it's 180 minus alpha. Okay, let's not overcomplicate things. This is 180 minus alpha. Yes, thank you. Thank you for pointing that out. Let's keep it simple. 180 minus alpha. The resultant force, according the resultant force squared, which is this one, yeah, this is what we're looking for, is 3 squared plus square root of 5 squared, so square root of 5 squared, minus 2 times 3 times square root of 5 times cos, and now cos 180 minus alpha. Now, if you know the properties of cos alpha, you will know that this is minus cos alpha. Let's see. If you just take your calculator and you find cos 60 degrees is 1/2, but cos 180 minus 60 is minus 1/2. If you do cos 30 degrees is square root of 3/2, and cos 180 minus 30. You can check that on a calculator. It works. The proof will be in the next assignment with a minus. So in general, cos 180 minus alpha is minus cos alpha. So FR squared equals 9 plus 5 minus 6 times 6 root 5, 6 root 5 minus cos alpha, so plus cos alpha. Okay, so we use this result. Okay. So resultant force squared is 14 plus 6 square root of 5 cos alpha. Okay. Now we'll need to do some trigonometry. So we need to find cos alpha. Of course, you can find alpha and then find the cos, but I'm interested in the exact result. So what I'm going to do, I know that tan alpha is 2. Tan alpha is 2. I'm going to square both sides. Square both sides. So tan squared alpha equals 4. Would it not be -6? It's positive because cos alpha is, yes, it's a double negative. So we're putting minus cos alpha. Tan squared alpha is 4, and tan squared is sine squared alpha divided by cos squared alpha. We know that tan is sine over cos. I hope everybody knows that. Tan is sine over cos. So tan squared alpha is sine squared alpha over cos squared alpha equals 4. And from here, sine squared alpha equals 4 cos squared alpha. And we know that sine squared alpha plus cos squared alpha is 1. So sine squared alpha plus cos squared alpha is 1. So sine squared alpha equals 1 minus cos squared alpha. So we use that into here. We use that here. Can you hear me now? Okay, perfect. Sorry about that. No, I think just my Zoom crashed and my Zoom overheated. Okay. By the way, how many? Oh, 52 people. That's very nice. So 1 minus cos alpha equals 4 cos squared alpha. And cos squared alpha equals 5. And from here, cos alpha equals what? Sorry, 1/5. Cos squared alpha equals 1/5. 1 over square root 5 plus or minus, of course, but because we know that cosine that alpha is an acute angle, we can simply say that, okay, that is, so cos alpha is 1 over square root 5. Okay, so we plug that in. F resultant squared is 14 plus 6 root 5, 1 over root 5. That cancels. So that's 14 plus 6, that's 20. The resultant force is square root of 20, which is 2 square roots of 5 kilonewtons. Um, 2 square roots of 5 kilonewtons. And no, normally you wouldn't give your answer as a square root, but because the question is in square roots, then it is acceptable to use the exact values in the answer. I mean, this is a mathematical model rather than a real physics question. So we have the resultant force, which is 2 square root of 5 kilonewtons, which is what, 4.6 kilonewtons roughly. And now we need the angle. We need the angle. Well, we can use different ways. I'd say so we need this angle, theta. We can use sine rule for theta. Can we? Yeah, we can, by all means. So we are looking for this angle. We're looking for this angle. This is theta. So using the sine rule, we do square root of 5 divided by sine theta equals 2 square root of 5 divided by sine 180 minus alpha. Sine 180 minus alpha. And there's a very similar result you can use for sine. Just accept it without proof today. I just don't want to get too deep into this. Sine 180 minus alpha is sine alpha without the minus. Sine 180 minus alpha is the same as sine alpha. Therefore, this is 2 square roots of 5 divided by sine alpha. Sine alpha. Okay, so from here, sine theta, the theta that we're looking for is sine alpha divided by 2 square roots of 5 multiplied by square root of 5. Square root of 5 cancels, so we have 1/2 sine alpha. And we already know sine alpha, or at least we know cos alpha, and we can easily find sine alpha. Yeah, we know, because we know we know that cos alpha equals 1 over square root of 5. And we know that sine alpha divided by cos alpha is 2. Yeah, because tan alpha is 2. And therefore, we can find sine alpha is 2 cos alpha, which is 2 divided by square root of 5. So it's 1/2 times sine alpha, which is 1/2. Half times 2. Half times 2 square root of 5. So 1 over square root of 5. Okay. And so we found theta. We found theta is arc sine 1 over square root 5. But I just want to make it slightly more elegant, and I'm going to do the following. I'm going to find tan theta. Tan theta will actually be 1/2. Tan theta is going to be 1/2, so theta is arctan 1/2, which is more elegant than this. Yeah, I do have to warn. these two problems are probably the hardest ones. So don't worry if you don't fully understand. If you don't fully understand the maths here. But I do hope you understand the physics, because you can always do it in a different way. You can break F1 and F2 into components. Actually, I'm going to show you how to do this, and maybe that will be way easier. Theta is arctan a half. So what I want you to appreciate is just the beauty of the numbers. So this is a mathematician in me that has woken up. So this is arctan a half, and alpha is arctan 2. Arctan 2. Yeah, is arctan 2, and this is arctan 1. And we got the result. But the bearing is our arctan 2. Well, not arctan 2, is so resultant force. So here, the answer. So whenever you are asked about to find a force or a velocity, do assume that you need to find both the magnitude and the direction. I think I mentioned that in the assignment. Mostly I've did ask you to do that, find the velocity, this magnitude and direction, but do assume that this is what you need to find. The force, resultant force is what is it? 2 square root of 5 kilonewtons. 2 square root of 5 kilonewtons. Direction, theta equals arctan. It doesn't like that. Arctan 1. Let's divide 1 arctan 2, which is approximately, and you should do arctan. Arctan is 10 minus 1, 0.5, which is 26.6 degrees. Okay, degree to the horizontal. You don't have to put bearing to the horizontal. Now, this is using cosine rule and sine rule, and I do have to say it's not optimal. So let's do the same thing, but using vector components. And something like this was in the assignments. So F1, F2. So this angle is alpha, which is arctan 2. Arctan 2, which is 63.4 degrees. 63.4 degrees. And we have 3, and we have square root of 5. So this is F1, and this is F2. So we write down them as components. So F1 is a column vector, which is 3, 0. That's an easy one. F2 is a column vector, so square root of 5 cos arctan 2. Cos arctan 2. 2 cos arctan 2 and square root of 5 sine arctan 2. And in fact, this is square root of 5 cos alpha and square root of 5 sine alpha. And we already know these. We know that 5 cos 5 is 1. Well, it's okay, square root of 5 times 1 over square root 5 and square root 5 times 2 over square root 5. So we can find f2. F2 is, it's a vector, of course. F2 is a column vector 1, 2. Okay. And the resultant force is 3, 0, 3, 0 plus 1, 2. You can use geometry to velocity to any vectors, because if you, as long as you know how to add vectors geometrically, and that's 4, 2. 4, 2. The resultant force is 4, 2. So 4, 2. And so you need to find the modulus of the resultant force. Modulus of the resultant force is square root of 4 squared plus 2 squared, which is square root of 20. Surprise, surprise. So it's 2 square root of 5 kilonewtons. And then the angle, theta is arctan of, so we need the arctan is the opposite is 2, the adjacent is 4, is 2 over 4, which is arctan 1/2, which is 26 point whatever, 26.6 degrees. Okay, which one do you like more? Components or column vectors or cosine rule? Put a column or cosine. Cosine or column. Column. Okay, overwhelmingly we have column because it is way easier. I actually just thought of this method on the go. Initially, I did it with this one, and yeah, this is way easier to do as a column. But do keep in mind that you can use cosine rule and sine rule for vectors, because why not? All right, now we get to a much more difficult question. So I think if you do it this way, this is why it would be a 2-mark question. It's just a lot of maths, but very little physics. You just need to see where physics ends, and physics ends right here. This is where physics stops. Now this is a much more physicsy question, and it seems like it seems like it's the same question. And I'm sure that given this problem without any context, without explaining that, without saying that this is a difficult question, if I give this question to Oxford University students, they would probably do it just like the one above. Okay, they would probably do it wrong. Let me just check my answer, not to embarrass myself. Yes, they would probably do it. They would probably do it completely wrong. So what is the issue here? Well, the issue here is that this velocity, v1, is not the horizontal component of this point. How would I say that? Okay, so you have a point. This is a point on the ship, so on the barge. So let's say there's a barge that looks like this. There's a barge. It has some load on it. This is a view from the top. Okay. If that wasn't clear before, that view from the top. View from top. And we have two tugboats. One is attached here, and the tugboat is moving horizontally. It doesn't mean that this point is moving horizontally. Okay, so this is V1. Now, it does, yeah, so this point is moving, but you can't just add V1 and V2. So V2 is here, because V1 is the V1 and V2 are velocities of the tugboats. They're not the components of the velocity of the barge. Because there's a rope in between. There's a rope in between. And as you know, if you pull one end of the rope, it does not mean that the other end is moving with the same speed. Am I making sense? An extreme case. An extreme case. Let's say attention to my video. Let's look at an extreme case. I have a rope. Well, this is my charger. Let me just adjust my video. I'm sorry, I can't adjust it on the go. Anyways, so I have a rope, yeah, and if I pull the rope in opposite directions, when I snap, the middle bit would be moving really fast. Imagine it's like a catapult. If I snap the rope really fast, this end is moving one way, this end is moving the other way, but the middle is traveling really fast upwards. So let's look at this case. So we have a slack rope. Well, a slack rope. And I'm pulling this with force F1, this F2. And the middle bit is moving up. Okay. Now, when the rope becomes horizontal, we still have F2, we still have F1, and the resultant force here, is 0, obviously. Okay. Now, but if you look at the velocities, at this particular moment, so my left hand is moving with velocity v1, my right hand is moving with velocity v2, but the middle bit, the middle part of the rope, is moving with an incredibly high velocity, like really high velocity, vr. Do you understand how well do you understand that there is a difference between looking at the resultant force and the speed of the middle of the rope? On a scale of 1 to 10, please. Okay. Good. Good. So there is a difference. If you look at the forces, the force necessarily is the same, necessarily zero at this moment of time when the rope just becomes straight. But the middle of the rope is still moving, and it's in fact moving really fast. If you were to measure the speed of a snapping rope, it will be incredibly fast in the middle. Therefore, yes, well, there is a resultant force, because as you can see, when the rope is not straight, there is a resultant force. And if you draw the same with the velocity, if you draw the same with the velocity of the middle is going to be like this. So this is v2, this is v1, and the middle will be moving up. But the moment when it becomes straight, the resultant force gradually decreases to zero, whereas the velocity actually increases to a maximum. The velocity is maximum when the rope is completely taut. And that's what happens. So here, when we pull with two forces, the total force is necessarily the sum of the two forces. When we talk about the velocities, because there's a rope involved, this point of the rope is not moving with the same, is not, so let's call it v. Let's call it v. Yeah. So v is not equal to v1 plus v2. It's not a case of simple vector addition. All right, so if it's not vector addition, so what is it? We have to go back to problem number 1, where we had a rigid structure which is not allowed to move. Now, this is like half of this rigid structure. So this, so I'll just write this down here. So let's say that this view from the top, and this is the point where the ropes are attached. And let's say this point is moving with velocity v, okay, with velocity v, at an angle beta. Now, if you look at this diagram, I think we need a new diagram just for it to become less confusing. So this is the point where the ropes are attached. This is one end of the rope. This is another end of the rope. This is V1, V1. This is V2, V2. And this is V. We don't know V, and we don't know the angle. V and the angle beta. And this angle is, somebody help me. What's this angle? Beta. No, this is beta. What is this angle? Alpha minus beta. Yes, well done. Alpha minus beta. Now, if we split this V into components along the first rope, this is the component of V along the first rope. So that's V cos beta. And because it is the same rope, the horizontal velocities have to be the same because the rope is inextensible. So V cos beta has to equal to V1. Now let's look at the second rope. So this is the component of V along the second rope, and this is V cos alpha minus beta. This is the component along this rope. So these are not the two components of V, don't get me wrong. This is the component if we were splitting along this rope. And this is the component if we were splitting along that rope. And because the second rope is also inextensible, we have to have V cos alpha minus beta equals to V2. Because they have to have the same velocity in that direction, in the direction of the rope, because the rope is inextensible. And now we use a formula for cos alpha minus beta, a little bit of trigonometry. So you'll have fun with trigonometry. Cos alpha minus beta is equal to cos alpha cos beta plus sine alpha sine beta. Sine alpha sine beta. And from the previous question, we already know that cos alpha, because it's the same angles, cos alpha is 1 over root 5, and sine alpha is 2 over root 5. So cos alpha minus beta is equal to 1 over root 5 cos beta plus sine alpha, which is 2 over root 5 sine beta. So we plug that into here. So this goes into here. So V, which is unknown, V multiplied by 1 if you can make your life easier, do it. Multiplied by that is equal to V2. Right, now V1, we know that V1 is 3 meters per second, and we know that V2 is square root of 5. That's given in the task. And so from here, we expand. So 1 over square root 5 V cos beta plus 2 over square root 5 V sine beta equals v2, which is square root 5. So we multiply both sides by square root 5. We get v cos beta plus 2v sine beta equals 5. And v cos beta, ooh, I think I saw that somewhere. That is 3. V cos beta is 3. So it's 3 plus 2v sine beta is 5. So 5 minus 3. So 5 minus 3 over 2. So v sine beta is 1. Oh, is it? V sine beta is 1. Oh yeah, it is. It is. And v cos beta is v cos beta is 3. We already had this before. Now, this one, I'll show you a trick which you will do very often quite soon. If you see v sine beta equals something and v cos beta equals something, you need to square them. You need to square both expressions. You get v squared sine squared beta equals 1. And v squared cos squared beta is 9. And now you add them. You add the two expressions and you get v squared sine squared alpha plus cos squared alpha equals 9 plus 1. 9 plus 1 plus 9. So, and this, we already know that this is 1. Well, you might not know this, but this is part of the next assignment. This is 1. This is equal to 1. So v squared equals 10. Now this is a neat trick. So whenever you have something like this, if you square them and add them, the sines and cosines go away because sine squared alpha plus cos squared alpha is 1. So v squared equals 10. So v is square root of 10. Ooh, remember the force? Oh yes, beta, of course. Sorry. This is beta. V square root of 10. And in the previous one, f was square root of 20. So it is different. It is definitely different. There is definitely a difference. So v square root of 10 and beta, well, you divide these two. You divide these and you get v sine beta divided by v cos beta equals 1/3. So tan beta, so v cancels, tan beta is 1/3. So the angle beta is arctan 1/3, which is approximately what? Arctan 1/3, 18.4 degrees. 18.4 degrees to horizontal. Right, meters per second. This is the answer. Okay. Any thoughts? Any questions? I should ask how how much have I confused you? Okay. I've got 2 questions left. This question is, well, it's very similar to the one on the assignment. So if you're struggling with question number, I don't remember, COMPOS. Is there an easy way to tell apart COMPOS? The method used to find forces and velocity. Well, I'm not sure how to answer this question, Vin. Is there an easy way? I'd say when you have a rope, like, I mean, this question just looks too good to be done just like finding the resultant velocity. Well, it does depend on the context of the question, but this is talking about ropes. I mean, when you have 2 velocities, well, so for example, we had questions where we had a river and a boat in the river. Now, if I tell you the velocity of the boat relative to if the velocity of the boat relative to the water is, I don't know, 10, and the speed of the river is 2, you can find the velocity of the boat relative to a stationary observer. Okay, so let's look at this example just to understand the difference. We have a river flowing at a speed 2 meters per second. And we have a ship going through the water, going through the water at, I don't know, 6 meters per second. 6 meters per second. Then we can easily find 2 plus 6. So 2 plus 6. So how much is 2 plus 6? Obviously it is square root of 40. Okay, square root of 40. So you can find the resultant. So V1, V2. So if you have a boat traveling at 6 meters per second and the river is traveling at 2 meters per second, then you have that. Okay. Now let's look at a different example. You have a boat in the water. There's a stream, 2 meters per second. 2 meters per second. And there's a rope. There's a rope, and the rope is being pulled at 6 meters per second. Now the problem is the speed of this end of the rope and the speed of this end of the rope, or the velocity of this end and this end, are not the same. Therefore, you can't just do 6 plus 2 here. This is a different question. Do you feel the difference? In the first case, you just add the velocities, because they give you the velocity of the boat relative to the water. And in the second example, they're giving you the velocity of this point. And here they're giving you the velocity of the other end of the rope. And that makes the difference. Does that make sense, Vin? Yeah, if the stream would still, yes, of course. But if the stream is not still, the boat would take a peculiar curve through the water. Velocity along the rope, yes, but not total velocity. Velocity of the velocity along the rope would be the same because the rope is inextensible, but there would also be sideways movement. There would be sideways movement in the boat, and that would make the difference. Right. So if we look at question, where was it? Vectors in physics. Towards the end. Problem 10. Vector v plus 3w is perpendicular to vector that. Vector 2 is perpendicular to vector. Find the angle between the vectors. Okay. So I'm doing a very similar problem here. And you can see even the wording is almost identical. Okay. And so what do we do? So this is perpendicular to this, and this is perpendicular to that. Find the angle between A and B. Well, if they're perpendicular, that means that if let's say vector C is perpendicular to vector D, then C times D is 0. This should work automatically for you guys. So we do 2A plus 6B multiplied by 5B minus 7A equals 0. Also, these are perpendicular, so 8B minus 2A. Now, I'm missing these vector symbols, but do assume that they're there. When you do the assignment, please do add the vectors on top. Just we're running out of time, and I do want to show you how to do this question. So you expand. So it's going to be 10AB minus 14A squared plus 30B squared minus 42AB equals 0. And here we have 16B squared, sorry, minus 56AB minus 4AB plus 14B squared. 13A squared, sorry. 14A squared equals 0. That's a B. And we simplify that. So we have 30B squared minus 32AB minus 14A squared equals 0. Here we get 14A squared plus 16. Is it 16? Yeah, B squared minus 60AB equals 0. Now you can add them. You can see that if you add them, 14A squared cancels. So 30B squared minus 32AB minus 60AB plus 16b squared equals 0. So we have 30 plus 30b squared plus 16, that's 46b squared, minus 92ab equals 0. In other words, b squared is 2ab. Now, these are vectors. So you would think that you can divide by b, but you can't. There is no division operation defined with vectors. Similarly, you substitute that into any of these. So you sub that into here, and you get 14a squared plus 32b squared minus 60ab equals 0. And you get a squared equals 2ab. Aha. So what does that tell us? Well, that tells us that modulus A is equal to modulus B. Modulus A equals modulus B. And therefore, modulus A equals modulus B. And now we need to remember that the cosine of the angle between two vectors is equal to A times B divided by modulus A modulus B. And AB, the product of the two, is actually A squared over A squared over 2. So that's going to be A squared over 2. And then modulus A and modulus B, this is the same as A squared. So A squared cancels, you get 1/2. So angle cosine theta is equal to arc cos 1/2. Because they are vectors. If a squared equals b squared, that simply means that the vectors have the same length. It does not mean that they are the same vector. Look, an example. You have a vector A. Let's say it's vector 5, 0. And you have a vector B, which is 3, 4. Vector B, which is 3, 4. Are they the same vector? Well, vector A is not equal to vector B. However, we know if you should by now, having done several problems with vectors, you know that modulus B is 5 and modulus A is 5. So modulus A is equal to modulus B. Right? So vectors have the same length, but they're not equal vectors. Now, in terms of A squared, so let's find A squared. A squared is 5, 0 multiplied by 5, 0. So it's 5 times 5 plus 0 times 0, so it's 25. B squared is 3, 4. This is a dot product. This is a dot product. 3, 4. So 3 times 3 is 9, plus 4 times 4 is 16. is 25. So the fact that these two are equal means this, but does not mean that the vectors are equal. So hope that makes sense. And you can find this using a calculator. So this is a very similar problem to that. Now, the last thing. The last thing is a very important one. Perhaps it is more like a question from assignment 3, which is in the future. This is a question from assignment 3, but it is vectors. So it looks confusing. Basically, what's happening here? You are moving from 1 to 3, and you're moving like this: 1 to 2, and then 2 to 3. There's a gravitational force F. The force is acting like this, and it does some work. We know that force is the work is force times the displacement. We know that work is force multiplied by the displacement. Displacement is delta R. In this case, delta R is the displacement. Delta R, force times delta R, is a dot product. Oh, sorry, no, yeah, the scalar product. Okay, so let's have a look. So for the first case, we have the force F, and we can see that it is equal to 1. So F is equal to 0 minus 1. Okay, this is a downwards vector of length 1. We know that it's vector 1. Yeah, I didn't say that use the scales, but you need to use the scales. In this particular question, use the scale. Delta R1, this is also a vector. Here it is. Yeah, and it's equal to 4, 2. 4, 2. Delta R2. What's delta R2? Somebody help me. Just put 2 numbers. This R2, delta R2. 0, 2. Well done. 0, 2. And delta R3. Delta R3 is 4, 4. Yes, 4, 4. Okay. The work done, moving from 1 to 2. Moving from 1 to 2 is force times delta R1. So that is 0 minus 1 multiplied by 4, 2. That's equal to minus 2. Minus 2 joules. Yes, a force can do negative work. Usually that involves slowing you down. Work 2, 3, work on the path 2, 3 is 0 minus 1 multiplied by 0, 2, which is minus 2 joules. And now we are moving along path 1, 3. So this is the object moves from 1 to 3 in 2 occasions. First, we move along 1 to 2 and then 2 to 3. And secondly, we move from 1 to 3 directly along the straight line. Work from 1 to 3 is equal to 0 minus 1 multiplied by 4 equal to minus 4 joules. So from here, we can see that the work 1-2 plus the work 2-3 is equal to work 1-3. Gravity does the same work if you move along 1-2-3 or 1-3 directly. This is a very important result. Okay, how well do you understand what just happened here? How well do you understand the maths, the physics here? So what I've done. So I found the work where there's no work done getting from 1 to 2. Ooh. No, there is. From 1 to 2 is minus 2 joules. It's not the work. It's not the work you do getting there. It's the work that gravity does on you. Because every single force does work. And if you move along, a path, gravity does work. So when you roll down a slope, gravity does work. Okay, so gravity does the same work if you move along 1, 2, 3, or. Now let's look at friction. Now friction has the same value. So F, and you can see F is 1 Newton. But we have 3 different forces. Let's call it F1, F2, and F3. Now F2, that's the easiest one, is 0 minus 1. F1, now it's 4 and 2. We need to scale it down. 4 and 2, 4 plus 2 is 16 plus square root of 20. So I don't want to overcomplicate things. F2. Let's make it 1. I mean, it doesn't really matter. Let's say it's like this. F2. I think it's just a mistake because obviously, so the friction force, we need to assume that the friction force is the same. It's 1 Newton here, 1 Newton, and 1 Newton. But the in terms of vectors, it's going to be different. So F1. So it's going to be 1 over square root of 20. So is it? So 4 plus 4, or 16 plus 4, yeah. And it's minus 1, so it's going to be minus 2. No, so minus 4 minus 2. And that simplifies to 1 over square. So that 1 over 2 square roots of 5. So minus 2 over square root of 5. And minus 1 over square root of 5. Just believe me for now. Believe me for now that F2 is that. You can check that it is 1 by adding the squares. So square plus 1 over square root 5. If you add the squares, that's equal to 1. So it does make sense. And I just don't have time to explain how I got here. And F3, because I kind of want to make a point here. F3 is diagonal, so it's minus 1 over square root of 2, minus 1 over square root of 2. and -1/√2. Again, if you square them and add them, it's going to make 1 Newton. And now the work done by, let's call it A12, work done by gravity going from 1 to 2. In physics, we very often use A for work, because A is German for Arbeit. Arbeiten. So don't be surprised if you see A for work. A1 to 2 is so it's F1 multiplied by delta R1. So F1 is -2√5 -1/√5 multiplied by delta R1, which is 4.2. And that is actually we could have used we could have done it much easier, because the force of friction. Sorry, that's completely useless, because what we actually need is we need the modulus of this. We need the modulus of this, and the modulus of this is square root of 20. The modulus of R2 is 2, and the modulus of R is this is square root of 20, this is 2, and this is 4 plus 4, so square root of 32. Square root of 32. And the work done is force times distance, right? But because the force is opposite to the distance, I mean, you could do it here, as in 4 times that, 2 times that, but in fact, it's going to be square root of minus square root of 20. A23 is going to be F2 multiplied by delta R2. So you multiply that, and that's going to be -2. And A13, moving along the path 1,3, is going to be F3 multiplied. So that's joules, F3 delta R3. And that's, you multiply those, and you get F3 is 1 times square root is going to be square root of 32 minus square root of 32 joules. And as you can see, the work done going from 1 to 3 is not equal to the work going from 1 to 2 plus the work going from 2 to 3. Now, this is a fundamental thing. This is a fundamental difference between the friction force and the gravitational force. And you will encounter this in assignment 3, I think, or assignment 4. Gravity is a conservative force. The work done by a conservative force is independent of the path taken. Friction is a non-conservative force. force. The work done by a conservative force, is dependent of the path taken. It depends on the path taken. And this is the fundamental difference between the two. Now, one consequence of gravity being a conservative force, one consequence of the gravity being a conservative force, that if you throw something up into the air, it comes back down. With friction, it doesn't work. If you throw something along the floor, it doesn't come back. So gravity is a conservative force. Friction is a non-conservative force. And well, I don't know if you'll appreciate. We had a joke when I was at university. When you do an exam, you come to the professor and you bring your mark book. You bring a piece of, well, you bring a book, you give it to the professor. They ask you questions, and then they put a grade into your mark book, and they give it back to you, and that's your grade. So that's a physical thing. And there was a not very good student from our course, and the professor said, "All right, I can give you a pass if you answer the final question. Is friction a conservative force?" And the student says, "Yes, friction is a conservative force." And he says, "Okay, you know what? I'll take your book and I'll slide it under the door. If it comes back, I'll give you an A." And he throws the book. There's somebody behind the door. He sees a book coming out. He thinks, "Oh, it shouldn't be here," and he throws it back. So yes, so friction with a conservative force, it comes back. With a non-conservative force, it doesn't. And the legend says that the student actually got an A, and the professor had a good laugh. Right. Okay. So, you have any questions? Any questions? Not concerning the not concerning the student that didn't study physics properly. Okay. Right. Okay, then I'll see you next week. I'll see you next week with more maths. And yeah, get ready to. The deadline is next Sunday. So please do submit it on time. You're welcome. You're welcome. See you. Sorry, I saw a question. Considering new students, where should you go for it started later as a result about the course? This is my first one. So yeah, look, so Robert, you're still here. I assume that Robert, and not yeah, not your profession. So basically, you can start at any time. It's just the problem is you have less time to do. You have about 12 days to do physics and maths, and submit it before the end of the 16th of October. Just go through the assignment. If you can do them, just do them straight away and submit. You can see all of my lectures. They are online. So go through the Telegram group, or go to Google Classroom. In Google Classroom, I've published all of the videos. So this is the 5th webinar. So I've done similar webinars in the 4 weeks preceding this one. So that hope that makes sense. Do watch the videos if you need, and if you don't need, then that's good. Okay. All right. See you. Yeah, go for it.